Hi. So I think probably pretty much everybody already knows. I'm Peter Singer from the University Centre for Human Values. This is the DeCamp Bioethics Seminars, though this time jointly with the Princeton Environmental Institute. We are very pleased to have Dale Jamison with us. Dale is Director of Environmental Studies at New York University, where he's also Professor of Environmental Studies and Philosophy, and he's an affiliated Professor of Law. He came to NYU a few years ago from Carleton College, and before that from Boulder, where I was fortunate enough to spend a semester as a visitor back in 1984. And already at that time, Dale was talking about climate change, certainly before I'd started thinking about it. And he was involved with the people at NCAR, the National Centre for Atmospheric Research, which is also in Boulder, spending time with them learning more about the science, and was concerned about the ethical implications of it. Dale's the author of Ethics in the Environment, an introduction published by Cambridge 2 years ago, an excellent introduction to environmental ethics for those who are interested, and Morality's Progress, Essays on Humans, Other Animals and the Rest of Nature, from Oxford in 2002. He's edited a variety of books, most recently Climate Ethics, Essential Readings, with Steve Gardner, Simon Caney and Henry Shue, and has published more than 100 articles and book chapters. He's currently a principal investigator on a National Science Foundation project on assessing assessments, historical and philosophical study of scientific assessments for environmental policy in the late 20th century, with our own Michael Oppenheimer and Naomi Oreskes from UCSD. He's also working on a book on moral and political challenges of climate change, one which you might say we're waiting for with bated breath, except that we would have turned blue a few years ago if we had held our breath too much. But we're looking forward to it coming out very soon. The response is going to be from Melissa Lane. Melissa joined the Department of Politics in 2009, and I should say is also a member of the Executive Committee of the Centre for Human Values. She came to us from a position at Cambridge University, where she was a Fellow of King's College and in the Department of History. Her research and teaching interests focus on ancient Greek political thought and its modern reception. And she's the author of Method and Politics in Plato's Statesman, Plato's Progeny, How Plato and Socrates Still Captivate the Modern Mind. And this one intrigued me because the very first text I ever read in philosophy as a first-year undergraduate was Plato's Republic. That was the text for the first-year course at the University of Melbourne. In the Penguin Classics edition, I can fondly remember. Melissa has written the introduction to the new edition. I'm sure I would have benefited from that if I'd been able to have it. She told me just today, I learned that she got interested in environmental issues, at least in part through being a faculty member of the Business and Environment Ethics Program of His Royal Highness the Prince of Wales. And this has led her to think more about environmental issues. And her current work includes projects on ancient ethics as a resource for thinking about sustainability. So that's enough for me. Over to Dale for geoengineering as a response to climate change. Thank you.
Thank you, Peter, for that generous and woefully accurate introduction with respect to my climate change book, which I'm glad I'm not waiting for with bated breath either. So first of all, it's always a pleasure and a great honor to return to Princeton, where at least I personally started the millennium by spending 2 very happy years here. So I want to say a couple things at the outset. First, as some of you know, I first got interested in ethical issues about geoengineering when I was invited to give a talk at a AAAS symposium on the subject in 1994. And that paper was eventually published in 1996 in Climatic Change. And the context of the geoengineering discussion is very different now. But I actually think in terms of the core issues, not very much has changed at all. And this is, and what you're really getting this afternoon is really my second systematic attempt to really think through these issues. And I hope it's just not a sign of impending old age, that I'm afraid I come out in a place that's very close to where I began. This is, again, the first of my attempts to think through these issues, again, in a systematic way. So it's very much work in progress. And one result of that is, this will seem a bit strange, I think, to those of you who aren't political theorists or philosophers, is that I have a PowerPoint. But the main reason I have a few PowerPoint slides is just to make those of you from the sciences feel reasonably comfortable in the room. There's really nothing on the PowerPoint slides that's very essential to my talk, or even very interesting for that matter. But I will try to remember to advance them when I should. So geoengineering is back with a vengeance. A rush of new books and official reports urge us to think seriously about addressing climate change by painting roofs white, injecting reflective aerosols into the atmosphere, or even by launching space shields that would protect us from solar radiation. This newfound interest in geoengineering is partly a reaction to the steady increase in greenhouse gas emissions, which has continued despite scientific consensus, international treaties, and solemn declarations. In the background is the fact that many of us find Promethean solutions almost irresistibly attractive. In this talk, I'll explain why conceptualizing climate change in the way that we do makes a hard problem even harder. I'll begin with a very general characterization of the problem, then critically discuss the vocabulary of responses. I'll suggest that while some specific geoengineering proposals are worth considering and researching, the general category of geoengineering should be put to rest. I'll then express some concerns about some of the most frequently discussed geoengineering technologies and suggest that research should continue while arguing against proposals for initiating a dedicated, mission-driven geoengineering research program. I'll go on to say a little about how we should go forward in addressing climate change and what role various geoengineering technologies might have in this effort. Finally, I'll draw some conclusions. So, Section 2, the nature of the problem. Almost everything about climate change is contested. Whether it is occurring, whether it is anthropogenic, whether it is a problem, whether it is soluble, what would count as solutions, and even whether any solutions would be possible. These disputes are important, but I will put them aside. I'll state the problem of climate change in a very general way and address myself to the community that is trying to address this problem in the terms in which I've stated it. The problem that we face, described in this general way, is that human action is increasing atmospheric concentrations of greenhouse gases, which are in turn producing climate change. The greenhouse gases that are of greatest interest are carbon dioxide, methane, nitrous oxide, and the halocarbons, a group of gases that include fluorine, chlorine, and bromine. While these gases have different properties, they are often discussed in terms of the construct global warming potential, with carbon dioxide stipulated as 1 and methane, for example, characterized as 72, meaning that each molecule of methane exerts 72 times the warming power over a 20-year period as a molecule of carbon dioxide. For present purposes, I'll focus mainly on carbon dioxide because it is the gas of greatest concern and because it is the one that is most widely discussed in the geoengineering literature, though I'll also sometimes speak generally in terms of carbon dioxide equivalents. Humans affect atmospheric concentrations of carbon dioxide by manipulating both sources and sinks. Humans manipulate sources by producing emissions through such actions as burning fossil fuels. Humans manipulate sinks by causing land use changes that reduce the ability of the biosphere to store carbon. Some actions, such as deforestation, can increase atmospheric carbon dioxide both by contributing to emissions and by reducing the ability of the biosphere to store carbon. Atmospheric concentrations of carbon dioxide are related to climate. In particular, high levels of atmospheric carbon dioxide are related to high mean surface temperatures. A doubling of atmospheric carbon dioxide would produce a 1 degree centigrade warming were there no feedbacks in the climate system. Because there are feedbacks, mostly relating to clouds, sea ice, and water vapor, a carbon dioxide doubling would likely produce a 2 to 4.5 degrees centigrade warming. The hottest controversies, if I can use that term, in climate science mostly concern the nature, strength, and even sometimes the identity of these feedbacks. The value associated with an increase in mean surface temperature, for example, 2 degrees centigrade, should be thought of as an index of the severity of climate change, rather than as a prediction of temperature changes in any particular region. Any warming will produce more extreme events and higher regional temperatures, though some regions may not change or even become cooler. A more extreme warming will produce more extreme events and a greater likelihood of higher temperatures overall. The 194 parties to the Framework Convention on Climate Change are committed to the objective of stabilizing greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. What constitutes dangerous interference is a value judgment based on scientific information. There is widespread international agreement, but not consensus, about this value judgment. We should regard a 2 degrees centigrade increase from the pre-industrial baseline as the threshold for dangerous interference with the climate system. In order to have a 50% chance of not exceeding the 2 degrees centigrade threshold, we will have to stabilize atmospheric concentrations equivalent to 450 parts per million of carbon dioxide, according to the most widely accepted estimates. In the nearly 2 decades since the Framework Convention on Climate Change was signed, little has been done to reduce or even to stabilize global emissions. Indeed, except during severe economic downturns, atmospheric concentration of carbon dioxide has been increasing at a rate of about 2 parts per million per year. It now stands at 387 parts per million, nearly 30% greater than the pre-industrial baseline of 275 parts per million. It is thus not surprising that attention is turning to various strategies that might help to compensate for this failure. Many of these strategies are clumped together under the rubric geoengineering. So, Section 3, the vocabulary of responses. Early on in the climate change discussion, there was a tripartite division of possible responses: prevention, mitigation, and adaptation. Now that prevention is no longer an option, the tripartite division is between mitigation, adaptation, and geoengineering. In my opinion, conformity to this vocabulary contributes to obscuring the issues. Mitigation, in the climate change lexicon, refers to reducing emissions. However, concern with reducing emissions is only tactical. The real objects of concern are atmospheric concentrations of carbon dioxide and the climate they affect. The atmospheric concentration can be affected by manipulating sources, for example, by reducing emissions, or by manipulating sinks, for example, by preserving forests or planting trees. In my opinion, we should follow the usual language of environmental policy by referring to all measures that reduce the pollutant of concern, in this case carbon dioxide and other greenhouse gases, as abatement. Adaptation, as it is used in the climate change discussion, refers to a wide range of responses, from building floating houses, for example in the Netherlands is occurring, to migrating to more secure parts of the world. Little distinction is made between adapting to a changing climate and adapting to the effects of a changing climate. I think this is a mistake. I would reserve the term adaptation for those changes that are direct responses to a changing climate. For example, the adoption of new seed varieties, the creation of irrigation systems. I would call responses to the effects of climate change, such as migrating from an area of climate-driven economic, political, or social upheaval, as attempts to mitigate the effects of climate change. Okay, so I think I'm one slide ahead of myself. Yeah. Geoengineering is a term whose origins are difficult to trace, but the idea has been in circulation for decades and perhaps centuries. In a 1961 address to the United Nations General Assembly, President John Kennedy declared his intention to, quote, propose further cooperative efforts between all nations in weather prediction and eventually in weather control. 4 years later, when the President's Science Advisory Committee produced the first U.S. government report discussing climate change, the only responses that were considered were those that brought about what they called countervailing climate changes. The possibility of covering thousands of square miles of ocean with reflective particles was specifically mentioned, but not a word was said about reducing carbon emissions. There is serious disagreement about exactly which technologies count as geoengineering. In 1996, Thomas Schelling characterized geoengineering as implying, quote, something global, intentional, and unnatural. Now, the first two criteria are relatively clear. Geoengineering technologies are directed towards intentionally manipulating climate, global climate. What Schelling is getting at by unnatural, I think, is that these are new, untried technologies, or technologies that would be put to new uses. Geoengineering is a Rube Goldberg category in part because scientists and engineers from different research traditions and disciplinary backgrounds have tabled proposals that reflect their own interests. Some proposed geoengineering responses, sometimes called carbon dioxide removal technologies, or CDR for short, would reduce atmospheric concentrations of carbon by increasing sinks, for example, by fertilizing the ocean with iron, or by capturing carbon directly from the air, so-called air capture. Like emissions reductions, these CDR technologies should be thought of as abatement. Other proposed geoengineering techniques would affect Earth's mean surface temperature by affecting albedo, for example, painting surfaces white, by blocking solar radiation, for example, sun shields, or reflecting solar radiation back into space, for example, stratospheric aerosol injection, space mirrors. These are rightly called solar radiation management techniques, or SRM techniques. Now, I'm not the only person to suggest that reforming the language is a good first step towards improving policy. Actually, Confucius advocated the same thing under the title of rectification of names. And there are others who've made suggestions about how the vocabulary of climate policy should change. Moreover, my proposal may not unfairly be regarded as excessively subtle, charitably to say that. The distinction between responding to something and responding to its effects is not sharp, and neither are some of the other distinctions that I propose. Furthermore, one and the same thing can fall into several of these categories. For example, painting roofs white is both an adaptation to climate change and an instance of SRM. However, despite overlapping categories and the lack of sharp distinctions, there are clear cases and important differences that are often obscured by the standard language of the climate change discussion. Whatever one makes of all of these complications, my main point is that we can discuss specific geoengineering proposals without accepting the idea that there is some general category of response that can usefully be thought of as geoengineering. To put the point crudely, let's talk about specific geoengineering proposals and stop talking about geoengineering in general. So why should we avoid talking about geoengineering in general? Well, one reason is because the concept is too broad. Technologies as diverse as space mirrors and white roofs are encompassed by this term. Moreover, the category is arbitrary. Tree planting isn't geoengineering, while installing an artificial tree is, even if their carbon sequestration effects are identical. When humans and beavers build dams, they are both geoengineering. Perhaps even Ricky Kimberly is geoengineering when she builds a sand castle on the Jersey Shore. Ricky Kimberly's a child. These examples may be ruled out because geoengineering is supposed to be global in scope. But it's a subtle distinction between installing an artificial tree or dumping some iron filings at sea, acts that are supposed to have global repercussions, and Ricky Kimberley's sandcastle, which in some small way does change the Earth. Geoengineering does not have easily drawn intuitive boundaries, and so seems too ubiquitous to mark a useful category. The most serious objection to treating geoengineering as a distinct category is that it invites us to see an entire class of strategies as a categorical rival to those approaches to climate change that are classed as mitigation and adaptation. However, the real problem we face is not in choosing the right class of responses, but rather in selecting and implementing a portfolio of particular strategies for responding to a problem that is urgent, multidimensional, and extended in space and time. Moreover, because geoengineering is typically treated as nearly cost-free and only to be used in the bottom of the ninth, there is a tendency to exempt proposals that are classed in this way from the critical evaluation that we give to other proposals, for example, building nuclear power plants. The picture that many people have is that implementing geoengineering technologies would be like giving an experimental drug to a dying patient. The usual norms and ethical principles would not apply. Geoengineering has even been called Plan B, as if it were the morning after pill for societies that don't practice safe consumption. Geoengineering is supposed to be the backstop that is going to gather up all those wild carbon molecules that are not otherwise being caught. Now, if metaphors were arguments, geoengineering would be home free. What these metaphors have in common is that they are meant to bring out a distinctive role that geoengineering proposals are supposed to play, in contrast to technologies classed as mitigation and adaptation. I do not believe that they should be viewed as playing a distinctive role, and I am not convinced that there is any distinctive set of norms that apply to geoengineering, or that geoengineering proposals should be exempted from any particular norms that do apply because they have been brought together in this weedy category. It's important to interrogate each particular geoengineering proposal for ethical, political, social, and economic acceptability in the same way and comparatively to the way that we examine other proposals for responding to climate change. Okay, so the next section is some concerns about what is called geoengineering. So now I'm going to speak the language of the vulgar, and talk about geoengineering as if it were a well-formed category. Okay, so first, unintended consequences. Now, as is typical in the discussion of technological innovation, considerable concern has been expressed about the possibility of unintended effects. These concerns have included the possibility that sulfite aerosol injection would disrupt the Indian monsoon, to the recent observation that phytoplankton blooms stimulated by iron fertilization can result in the secretion of toxins at concentrations that can be harmful to marine life. These are important and serious considerations, but I want to focus on others that have received less attention, in my opinion, than they deserve. So, next, magic bullets. Even under very optimistic assumptions, there is no geoengineering technology that is a magic bullet, to use another metaphor, for addressing the problem of climate change. Particular geoengineering techniques would only solve some problems caused by our greenhouse gas emissions while neglecting or exacerbating others. For example, managing solar radiation might reduce mean surface temperature, but could have disruptive regional effects, for example, on the Indian monsoon. Nor would it do anything to address ocean acidification. Even worse, if we were to embark on solar radiation management while continuing to increase the atmospheric concentration of carbon dioxide, we would risk catastrophic climate change if we were to lose the capacity or will to manage solar radiation any time over a millennium or even longer. Now, I think it's interesting to think about what what humans have done in terms of societies and cultures and civilizations that they've been consistently able to do for centuries or for thousands of years. I mean, there are some interesting examples, I think, about maintaining water systems and irrigation systems and so on, but we're very hard put to come up with those examples. Now, removing atmospheric carbon dioxide avoids some of these risks, but depending on the rate of withdrawal, could have unpredictable climate effects. It would also be extremely challenging to create the infrastructure that would be large enough at such a scale that would offset global climate. It would also be challenging to successfully sequester carbon for centuries or millennia, as such schemes may well require. Of course, the most immediate and direct threat of such programs is to local ecosystems. Okay, declaring a climate emergency. Many people think that geoengineering technology should be developed, but only deployed in case of a climate emergency. Now, it's always struck me as being interesting that people who talk about geoengineering don't talk about implementing it, they talk about deploying it. This military term, I think, is somewhat revealing of the origins of the thought. Now, this raises several questions. How do we know when we face a climate emergency? Who has the authority to declare such an emergency? Once such an emergency is declared, could such technologies be deployed on a timely way in order to save us? Now, there are several problems with knowing when we face a climate emergency. The first problem is that one person's emergency is another person's bad day at the office. At the same time, there are people living today in drought-stricken regions of the world who would say that a climate emergency has already arrived. The problem is that the concept of an emergency is also value-laden, and while it is possible to get widespread agreement about such matters, as we saw about the 2 degrees centigrade threshold for dangerous anthropogenic interference, the recent recommendation of Congressman Gordon that, quote, the global science and policy communities should work towards consensus on this matter is hardly encouraging. A more serious problem is that the effects of climate change occur over centuries and even millennia. Were we able to see clearly from here what all the effects will be of the greenhouse gases that have already been emitted, perhaps we would agree that a climate emergency is already upon us. The problem is that we cannot see all the effects of our emissions because they are so dissociated, temporally and otherwise, from their causes. By the time we might come to an agreement that we are in a climate emergency, there may be little to do but watch it unfold. Or perhaps at that stage, the appropriate responses would be attempts at radical adaptation and survival, rather than trying to exert control over climate. Now, many people do say in the literature that solar radiation management technologies could be rapidly deployed, and this is a claim, I think, that I don't fully accept, but it deserves further discussion. An even more troubling question concerns who has the authority to declare a climate emergency. There is a great deal of talk in the geoengineering community about the importance of what are called governance issues. At the same time, there is concern that any truly inclusive governance process would not be able to act decisively in the face of a climate emergency. And you only have to look at the climate change negotiations, sadly, to be reinforced in that belief. Now, it might be said, I think a little unfairly, that many in the geoengineering community think that governance is good so long as it rapidly comes to the right decisions. Now, probably many of us think much the same thing about democracy, but are a little bit shy about asserting those sentiments. Now, there are very serious issues at stake here. Intentionally changing climate is a way of exerting power on a global scale, in a context in which relevant norms, conventions, and treaties either barely exist, are highly ineffectual, or very controversial. John von Neumann predicted in 1955, quote, intervention in atmospheric and climatic matters will unfold on a scale difficult to imagine at present. This will merge each nation's affairs with those of every other more thoroughly than the threat of a nuclear or any other war would have done, unquote. Climate change whether inadvertent or intentional, involves winners and losers at many different scales. Even countries that would benefit from geoengineering value their autonomy and their right to engage in decision-making. Any attempt to assume the authority to geoengineer without broad international agreement would be extremely divisive and disruptive. Indeed, outside the geoengineering community in the United States and Britain, suspicion about these activities is very great. We got a taste of this fall in Nagoya, Japan, when the parties to the Convention on Biological Diversity, a treaty which the United States has signed but not ratified, declared a moratorium on geoengineering research that would affect biodiversity. Now, generally, I think it is distasteful to quote oneself. But what I said on this topic in my 1996 paper seems to me still to put things as right as I can put them and to present a challenge that still has not been met. So here comes the distasteful part. Independent of the substantive question of who would win and lose, there is the procedural question of who would make the decision to undertake intentional climate change. Climate is a global system that affects everyone on Earth. In some ways, those in poor countries are even more affected by climate than those in rich countries, since in many cases they have less ability to protect themselves from climate impacts. The climate change that may now be occurring is largely caused by people in rich countries and their ancestors. People in poor countries were not consulted about the wisdom of changing climate, nor have they reaped much benefit from the activities that may be resulting in climate change. Just as poor people in poor countries, those who are in the periphery, even of the periphery, did not give their consent to inadvertent climate change, so it is unlikely that they would be asked to consent to intentional climate change. A decision to undertake intentional climate change would likely be made by the same people who are causing inadvertent climate change and have reaped most of the benefits from fossil fuel-driven industrialization, people in rich countries and their political, social, and economic leaders. But if the world belongs to anyone, it belongs to the poor as much as to the rich. And no decision to go forward with intentional climate change could be morally acceptable that did not in some way represent all of the people in the world. Even if people in poor countries would benefit from intentional climate change, it would still be wrong to change their climate without their consent. In principle, it might be possible to design a deliberative procedure that could render a just decision about intentional climate change. However, such a procedure would be unwieldy because it would have to be representative of everyone on Earth and not just the global middle class. Some may even think that other non-human living things should be represented in such a decision procedure. In addition to who should be represented and how, decisions also arise about what would constitute a mandate for action. Would it require unanimity among nations, a simple majority, or a decision of the United Nations Security Council? Indeed, it can even be questioned whether nations are the proper vehicles for making such decisions. However these questions might be answered, the bottom line is that unless conditions change radically, there is unlikely to be a democratic decision authorizing intentional climate change. There would be too much risk involved, and too many people would be afraid of losing what they have, however little it may be. Still, I doubt that this would be the end of intentional climate change. The same people who are avoiding and evading the difficult decisions that might prevent or mitigate inadvertent climate change might well decide to implement intentional climate change if they felt it was in their interests. And I think the big change from 1996 to now is that we're moving closer to making that decision. Okay, moral hazards. Many people, even some prominent proponents of geoengineering technologies, such as David Keith, have expressed concern that geoengineering research will distract us from the basic challenge of reducing carbon emissions. I believe that talk about geoengineering has already, to some extent, contributed to dampening our willingness to reduce emissions. As I've mentioned, people were talking about geoengineering in the 1960s. The historian Jim Fleming has demonstrated that there has been unbroken interest in geoengineering for decades, even perhaps centuries. I'll provide just one further example of how the possibility of geoengineering has figured influentially in the climate policy debate. William Nordhaus, arguably the most influential economist who works on climate change issues, writing in Science in 1992, immediately after the Rio Earth Summit, the adoption of the Framework Convention on Climate Change, and the promise by the United States and other developed countries to stabilize their greenhouse gas emissions, wrote the following, quote, "Geoengineering would introduce a hypothetical technology that provides costless mitigation of climate change. This could occur, for example, if one of the geoengineering options proved technically feasible and environmentally benign. Two interesting proposals include shooting smart mirrors into space with 16-inch naval rifles, or seeding the oceans with iron to accelerate carbon sequestration." So my point is that the dream of geoengineering, which is, as Nordhaus puts it very well, which is the dream of costless mitigation of climate change, has been already a constant presence, even if in the background, of the climate debate. And I think, to some extent, has already functioned as a moral hazard with respect to reducing greenhouse gas emissions. Now, my fear, then, is not that, since I think that's a fait accompli. My fear is that the interest in geoengineering will increasingly become a moral hazard with respect to adaptation as well, driving out funding, especially for the poorest populations who have done the least to cause climate change and to whom it poses the greatest dangers. Geoengineering is increasingly being marketed as a technology that will most benefit these poor people, precisely because they will suffer most from climate change. So on Plan B, rather than spending trillions of dollars to curb our emissions, adapt, or compensate the victims of climate change, we'll give our own scientists billions of dollars to prevent the bad consequences of climate change from ever occurring. It is this emerging vision that is the second, and I think currently most threatening moral hazard that's posed by geoengineering. Okay, arrogance. Geoengineering strikes many people as arrogant, both because it fails to show respect for nature and because it is of a piece with attitudes that have been implicated in causing the problem of climate change in the first place. Many of our environmental problems flow from attempts to manipulate nature in order to make it conform to our desires, rather than forming our desires in response to nature. We have, quote, improved nature in many ways, bringing water to places where people want to live, exterminating animals who prey on animals we raise for food, dredging harbors, filling wetlands so towns and cities can be developed. Although it is not possible or desirable for humans always to, quote, let nature take its course, there is a growing sense that modern societies have erred on the side of excessive intervention, that we have become arrogant and intrusive in attempting to manage all elements of nature. Now, one response to this concern is to say that geoengineering is directed towards reversing the inadvertent climate change that people already are bringing about. The goal of geoengineering is to return the climate system to its original state before humans began to affect it. Now, one may ask, of course, what counts as the original state, and what would be so special about whatever was designated as the original state anyway? If we're able to get our hands on the global thermostat, why should we settle for anything less than the best? But putting this question aside, many people would respond that two wrongs do not make a right. Geoengineering, rather than righting a wrong, would just add a second wrong to the first. Indeed, many people would say that the second wrong of intentionally changing climate would be worse than the first wrong of inadvertently changing climate, even if this second wrong did return us to the original climate, whatever that may be. Now, this common sense view supposes that there is an asymmetry between what is brought about intentionally and what is an inadvertent result of an action. While I don't believe that common sense can be fully defended on this point, it is surely not generally true that intentionally performing some act is equivalent to or not worse than inadvertently performing the same act. Intentionally running over a pedestrian is generally regarded as worse than doing so inadvertently. Indeed, when trying to evade responsibility for an action, people often claim that what happened was not what they intended. They didn't mean to do it. In some cases, intentionality is crucial even to how acts are classified. Intentionally running down a pedestrian is murder. Inadvertently killing the pedestrian is an accident. Intentional deception is lying. Inadvertent deception is leaving a false impression. There is much more to say here, but the simple thought that geoengineering cannot be an act of human arrogance because it's an equivalent but better intentioned version of an act that we do not consider arrogant simply does not, on the face of it, follow. Okay, so now the risks of research. Most geoengineering advocates say what they want is not deployment, but a dedicated research program. The program would start small, but could gear up to the scale of the Manhattan Project. They claim that there is a bright line between research and deployment. Bright lines, however, have a way of fading, particularly when it comes to dedicated research programs. In 1983, President Reagan created the Strategic Defense Initiative, a program devoted to developing technologies that would protect the American homeland from nuclear attack. Despite large costs and opposition from many of the nation's leading scientists, Reagan's initiative has survived in some form for more than a quarter century, focusing on different technologies and wrapping itself in different purposes. It led the United States to withdraw from the Anti-Ballistic Missile Treaty in 2002. It's increased international tensions on numerous occasions, and it siphoned money away from more valuable uses towards these technological fantasies. Large research initiatives can be tougher to kill than vampires. They feed fortunes, careers, and reputations. As with the Strategic Defense Initiative, a dedicated geoengineering research program risks creating a self-amplifying cycle of interest groups and lobbies, building momentum toward eventual deployment as a way of justifying the research. A dedicated geoengineering research program is especially dangerous in the current unstable policy environment, in which there is a large amount of goodwill backed by large sums of money in a context in which there is little regulation. At least one company, Planktos, set sail in an attempt to fertilize the ocean, hoping to be capitalized by the carbon offset market. The voluntary carbon offset market is estimated to be worth more than $700 million. Successful attempts to appeal to this market could eventually lead to being part of a regulated offset market that is potentially worth billions or hundreds of billions of dollars. It is not too difficult to imagine that something like the medical pharmaceutical complex could emerge in which research, deployment, marketing, and government policy are closely linked and mutually reinforcing. Given the huge sums at stake, it is not surprising that the push for a dedicated research program is so strong and comes from so many different directions. What is often ignored is that according to a recent GAO report, the United States government already spends upwards of $50 million per year in geoengineering-related research. This in addition to private spending. There is a case for better coordination and perhaps for increased funding, but it matters enormously how the research is conceptualized, what agencies lead, and whether it is regarded as mission-driven or basic research. So then, finally, the way forward, a portfolio of responses. And in some sense, I feel this is where the paper should begin, but maybe it's where the next paper begins. In the next few years, climate policy is likely to be driven by national and regional efforts, rather than by large schemes and big dreams about global cooperation. In every country, there are political divisions about how to respond to climate change, and domestic politics will become even more important in determining the global response. U.S. policy in the next several years will be driven by the effectiveness and resiliency of such laws, policies, and institutions as RGGI, California's climate change law, and attempts to regulate carbon dioxide under the Clean Air Act. In this environment, it is even more important to think in terms of Rob Sokolow and Steve Pacala's notion of wedges, only now projected out at different timescales, going beyond what was in the original paper. Some geoengineering technologies may have a place in our portfolio of responses, but they will have to compete against renewable energy projects, conservation, adaptation programs, and other alternatives on grounds of cost, feasibility, and moral and political acceptability. The approach that I have just begun to sketch amounts to abandoning the Promethean dream that is so ubiquitous in our thinking about climate, and entering the messy world of small ball climate politics. We have created a problem of climate change, and we must mobilize all of our resources in addressing it. But John Wayne is dead, and there is no Colt 45 peacemaker in sight. Thank you very much.
So it's a privilege to have the opportunity to comment on work by Dale Jamison, who's done so much pioneering work in environmental ethics and politics, and not least with respect to today's topic in his 1996 article on ethics, ethics and intentional climate change. I'm going to organize my comments in three sections. So first of all, I'll comment mostly applauding and arguing that we should extend his recategorization of the concept of geoengineering, his conceptual critique. And then secondly, offering a couple of additional points of diagnosis of why what we now call geoengineering so much appeals to many people. And then thirdly, looking at one aspect of his critique, in particular the point about arrogance, and I'll close with just a word about politics. So recategorization, diagnosis, arrogance, or critique, arrogance, and then politics. So I think that the critique which he's given us this afternoon of the conceptual and political failings of appealing to this general category is very important and astute. And I'll just comment on it. So I think conceptually, he's right to say that the category obscures the common aims and effects of certain strategies, such as carbon dioxide removal techniques, with standard strategies of what's usually called mitigation, by which people mean emissions reduction. And I think he's right to say these should all be considered part of abatement on the standard pollution model. We might even need to go one step further. It wasn't quite clear to me where he wanted to put solar radiation management strategies, and it might be that we should have some overarching category of harm lessening, of which abatement of the pollutant is only part, and then the SRMs are another part of the harm lessening category. So it would be interesting to know if that's how he's also thinking of it. And just one more parenthetical remark. I had a little trouble with the distinction between the response to climate change and the response to the effects of climate change, and it would be interesting to hear more about that in the discussion. And I might say also, just on one note, that Plato also was greatly concerned with the rectification of names. So this is a very wide-ranging ancient concern. I think politically, his critique is also very important about this sort of salvation fantasy of a costless mitigation of climate change. And the general message of that first part of the paper, that we have to interrogate each particular proposal rather than exempt the category as a whole, I think is extremely important. We might think that the recategorization should even be taken one step further. So why shouldn't tree planting, if it was done on a massive scale, count as geoengineering, or at least part of the family of harm lessening abatement techniques? And I think that there would be advantages to that even broader recategorization to highlight these continuities between our various ways of affecting the planet, rather than to allow us to indulge in the fantasy of some novel, clean, and safe way, which has nothing in common with these older, messier forms of intervention. And we might compare the discussions around genetic modification about a decade and a half ago, where I think it was a help to the debate when people pointed out that traditional methods of breeding plants and animals were also GM. So it wasn't that the genetic modification per se was the problem. It was the specific companies, the specific purposes, the specific safeguards that were brought to bear, rather than the fantasy that there was some prior human non-intervention in genetics, which these new techniques of genetic modification would suddenly alter. So I think that the recategorization point is very important, but I'm going to go on as Professor Jamison did and use the language of the vulgar, as he called it, in the rest of my talk, and just talk about geoengineering to mean the current package of strategies that people put under that heading. So the second point is I wanted to offer some further reflections on diagnosis. And I initially thought of these as sort of beyond the magic bullet, or things that are in addition to the magic bullet. It may be that they're actually ways of unpacking what do we mean by a magic bullet. So either way. But it seems to me that there's two further aspects to why this category has such appeal to people. And the first is the contrast between changing incentives, which most of our mitigation strategies rely on, and the idea of a direct intervention to bring about a desired effect. So most current mitigation strategies rely on changing incentive structures by carbon pricing, either by cap and trade or carbon taxes. And the effects of this, even of a tax, I think, can only be roughly predicted. People might just flout the tax or decide to pay the tax and go on emitting. And certainly with cap and trade, one of the problems is that it's hard to exactly predict what people's responses to setting the price at any given level is going to be. Their behavior might prove stickier than the setting of the price anticipated. So even if we were to succeed in establishing a global carbon price and deepen liquid global carbon markets, which has been the kind of goal of most environmental efforts on the mitigation side, the impact on what Professor Jamison rightly called our ultimate object of concern, which is atmospheric concentrations of carbon dioxide and other gases and the climate they affect, will be delayed and uncertain. Even if we were able to achieve a sort of global implementation of something better than Kyoto tomorrow, we still wouldn't know what the outcome on the climate was going to be. And I think it's in contrast to that geoengineering techniques seem so appealing, that they seem to promise a direct and an immediate intervention in exactly what we really want to affect, namely the effects on climate, or at least in the case of some of these techniques, the effect on climate. Now, of course, that seeming certainty is hostage to unintended and unpredictable consequences, but I think that's still its appeal. And the second aspect of its appeal, I think, is the structure of action, again, that's needed to bring about change. And maybe this is just what's meant by magic bullet, but I think it may be important to highlight that, again, the effects of carbon pricing are going to depend on billions of individual decisions aligning with the pricing incentives. And by contrast, geoengineering is something that one or a few agents can do. And I think that many people find this comforting. They're tired of this structure of decentralized, dispersed decision-making and want something that some one government can just decide to do. Now, of course, that brings with it all the dangers of illegitimacy and unrepresentativeness that Professor Jamison raised. But I think we should be realistic about the comparison class here. I think that having global democracy as the sort of standard is really unrealistic, that the real standard should be something like the UN Security Council or something like that. That's far from perfect, but at least that's the kind of standard of global legitimacy that we're able to put into effect for other kinds of decisions, however flawed it is. Okay, so that brings me then to my third point, which is commenting on the critique. And I'm just going to focus on one aspect of the critique that he offered, namely the arrogance point. But let me just preface that with some more general remarks about critique and how we should assess the balance of risks in this area. And I do think that, that considering this question today, and particularly in the wake of the midterm elections in America, makes this look very different from what it might have seemed even only 2 years ago, let alone in 1994 or 1996. While it might well be that abatement through emissions reduction is the safer and more moral choice, that solution seems to be rapidly receding out of reach in terms of the necessary time horizon. And Eli Kintish has put this problem starkly in his book called Hack the Planet, which is one of a series of new books about geoengineering, where he says, to cogently oppose geoengineering research, one has to accept one of two faulty propositions. Either the problem is not that serious, or we're on our way to solving it. And these days, one will be hard-pressed to find many takers for either. And I think we have to really take that seriously. We have to deny one of those two propositions, or we would have to accept either of those propositions, and I don't think we really can easily accept either of them. And so that bears on this question about the overall balance, which I think we rightly have to assess, as he said, for every given strategy and every given technique, And it also bears on the question of research and indeed of timing. One might conclude from the point about timing and that we can't wait for an emergency, it'll be too late, that maybe we have to act sooner, and that's a reason for doing research sooner rather than later. So I just want to say that I think the balance of where these considerations come out, while they're all real considerations, is not so clear, at least to me. So let me finally say something about the argument about arrogance and the way that was presented. And Professor Jamison distinguished between the inadvertent climate change that people are already bringing about and the second wrong of intentionally changing climate. So I have two questions about this analysis. So first, I'm not sure that inadvertent is the right category for our current actions. I mean, certainly all actions up till, say, 1896, when Arrhenius identified the greenhouse effect, were inadvertent. Beyond that, you have to draw a line, at which point one says, well, knowledge of the effects of emissions was widespread enough among either scientists, among policymakers, among the public at large, maybe 1992. But at some point, I think we crossed the boundary of inadvertent. And what we now have to say is that it may be that these emissions they're certainly conscious, and we're conscious of their effects. We might apply a double effect analysis and say they're not our primary intention, but I think inadvertent is really too light a category for the current state of our actions. And indeed, those conscious actions are, of course, in their effects at least as unpredictable, as uncertain, and as potentially irreversible as any of the geoengineering proposals. So it seems to me that the real comparison is not only between geoengineering and other strategies for abatement or mitigation, but it's between geoengineering and what we're doing now. So we're now consciously not aiming at this, but we know that we're bringing it about. So in some sense of intended, we're creating these harms. Now, so what would it mean then to say that geoengineering would be simply adding a second wrong to this wrong that we've already committed? And that seems to me much too fast, because certainly our aim in doing geoengineering wouldn't be to commit a wrong. We would be aiming to mitigate the harm that we've already been doing, and we would be doing that on some kind of balance of risk. So it might be that we ended up doing harm, but it seems to me that it's a stretch to condemn that as simply doing a second wrong to add to the wrong that we're already doing. And then finally, what kind of concern really is arrogance here? Is the particular concern with arrogance? And there seem to me to be several things wrapped up in this section. So one is that in our arrogance is that, our history shows that we're just likely to get it wrong, that we're likely to be too arrogant about knowing the consequences and thinking that we can get them wrong. And that might well be true. It might be that that's right, that the history does show that. But then that's really a concern with unintended consequences. I don't think it's really a concern with arrogance. Arrogance is just evidence that we might inflict unintended consequences. Or the second thought seems to be that it's just that arrogance means that we just get to intervene again in a Promethean way, and somehow that's wrong because Promethean intervention before was wrong. This kind of Promethean intervention is also wrong. But I have trouble with the thought that the fundamental wrong there would be a wrong about arrogance. Surely the wrong would be the harm that it would do. And so the real question is, again, about the risk of harm, the balance of harm, and the risks that we're willing to act on. And I would be more inclined here to follow a sort of tort law model, which would suggest that if we can compensate for a wrong, what would have been a wrong, by compensation that's equal to the harm done, then that's a good thing to do. And we may empirically doubt that that kind of compensation can be sufficient, but I'm not sure that we can just appeal to the moral origin in order to block that move. So I have my doubts about how much arrogance is really an issue in this area. So finally, just one closing remark. I couldn't help but think, again, as a political theorist who's worked on Plato, about Karl Popper's critique of utopian social engineering, which he advanced originally partly in the context of his critique of Plato in 1945. And his critique of utopian social engineering was that no social scientist should imagine that they can remake society from the ground up, treating all of society as their lab experiment, and therefore risking irreversible, drastic consequences should the experiment go wrong. But again, it seems to me that it's very important to realize that the comparison class here isn't, should we do this or not? It's rather that we're now doing dystopian social engineering. We're doing everything that Popper recommended against. That's exactly what we're now doing. And so I agree absolutely with the spirit of Professor Jamison's remarks that we have to look carefully at any strategy that purports to be a solution to this. But I also think that our standard can't be that the safest thing is to do nothing. The status quo is also a status quo of great danger and moral harm, as I know he would agree. Thank you.
Do you want to make a brief response to what?
No, I mean, there are lots of good points that are raised there. I mean, if the audience runs out of steam, then maybe I'll say some things. But I guess I'd like to hear the comments and questions.
Okay. It's unusual for us to run out of steam in the time we have, but you never know. It could happen. Who would like to go first? Tim.
So I suppose my question is about how the different bits will talk together, right? So your first claim is this idea that we shouldn't pick out geoengineering and treat it as a separate category. And then you've got a list of things that are wrong with geoengineering. And I mean, one immediate question is how consistent that's meant to be. So are these things that are wrong? What's wrong with those things is that because we're preoccupied with geoengineering, we have these problems, or these are problems with just doing geoengineering on its own, or are they problems that are in fact peculiar to geoengineering and that would still be problems if geoengineering were part of the mix? And so one way of turning that into a proper question would be to say, suppose someone who's suspicious of geoengineering comes along and says, well, actually, there is a genuine separate category, which is specifically those responses which are subject to these particular objections that you make. And that's when someone says, I don't like geoengineering, what they're meaning is, I don't like the things that involve the particular problems that you're raising.
Okay, I think what I had in mind is somewhat different from the ways that you were sort of developing the thought. But here's how I think it goes for me. So, first of all, I don't like the category of geoengineering for two reasons. One is, whatever loose notion of the natural kind you might think is operating in this area, geoengineering isn't even up to that, right? So it looks like a pretty stipulative category that's sort of held together by, among other notions, some idea of novelty, certainly part of why things get classed in there. But then the second point is that thinking in terms of these categories is really the wrong way to think about the choice situation that we're really in. That we should be thinking essentially about a portfolio of approaches and not about whether we should be mitigating or whether we should be adapting or whether we should be geoengineering, which is all too often how the discussion gets structured. Having made that point, at least to my reasonable satisfaction, then in the next part of the paper, I turn to discuss some of the technologies that are fairly stipulatively, as I understand it, classed together in this category of geoengineering, and make some remarks that are cautionary remarks about the use of those particular technologies. Now, in making those cautionary remarks about the use of those particular technologies, I don't mean to be saying there are no conditions under which they should be employed, because that would be inconsistent with what I was saying earlier in the paper, right? But there are going to be some of these technologies that may in fact have some role to play in how we respond to climate change. It's just that we're going to have to break them out and look at them comparatively to other approaches and technologies that we throw into these other categories. So, does that help?
Right, so they're not, so your list of problems, those are not problems that necessarily that are peculiar to geoengineering.
Sorry, they're not problems that are
peculiar to those particular technologies, as opposed to, say, mitigation. I mean, someone might say there's no international democratic mandate for cap and trade, there's unintended consequences there, it's equally Promethean, it's equally...
Okay, I think you're bringing out a nice distinction that I didn't make in that list of cautions. Some of the cautions are about the use of particular technologies. Other cautions are more like cautions about the rhetoric of geoengineering. So, for example, the moral hazard concern is really a concern about the deployment of this category, right, and the use of this category of geoengineering. Some of the other cautions are really cautions that are meant to apply, I think, to some particular technologies. So that's a helpful comment.
Fascinating talk, fascinating comment. Let me suggest that what word geoengineering really is a synonym for end run.
For what? Sorry?
Another metaphor.
End run.
End run. Okay, all right. That's a football metaphor, is it?
Why?
Right.
Yes, it is. You get around a little less blocking and go around the side.
Sorry, I'm not onto American football, but, you know.
There's no end runs in Australian rules football. There's just bloody-minded bashing your way.
We won't get into that discussion.
I mean, because it is a very motley set of things that are being given this name, and it seems to have some staying power, even though people have explained that they are so very different from each other. What do they have in common? So the Sesame Street question. And what they have in common is that they let us do what we've been doing. Or at least they have nothing to do with what we've been doing. So we can go on burning coal, cutting down forests, and this will somehow compensate. And maybe, and that, wouldn't that be nice? So, you know, you put up, you're taking CO2 in the atmosphere with the coal plant and simultaneously pulling it out the ocean, and you don't have to stop burning coal. So, I mean, it really is all about that, and therefore the moral hazard is first order. It's not, doesn't accidentally come along. That's the thing, you know, listening to it, it's what came to me. What do these things, why do people want to keep connected? Second thing is, as the first question was, some of these things are very different because they deal with emergencies. And I want to encourage you to keep deconstructing what an emergency is. Because among other things, you have a hammer and nail problem. You may actually get some strategies that deal with some emergencies. But the list of emergencies will include some things those strategies aren't actually going to help you with. Do other things. Argument that we should develop the ones that respond to emergencies is a very specific argument. And it comes from, to my mind, I didn't like the way Eli Kimmich sets up that problem, because you can have the best of intentions and the climate is just ornery and something has in the way of positive feedback happens, even though you've been a goody-good. And that would argue that you want to have some of this around. The policy question, we will see it in the U.S. Congress in the next 2 years. Should we fund research in this field? And we can focus on that. One question, quite a bit of what you say bears on it, some of it explicitly. Should we fund the research? And one answer is yes, because we want to have this option, this emergencies option, even for some emergencies. Another is, if we're exaggerating the cheapness of this and the efficacy of this, it's good to know that so we don't count on it too much. I think that's actually a justification for doing this. On the other side, it's a tremendous distraction. You don't give that much effort. And it's, what was my other one? It could, the slippery slope. I mean, it really could be impossible. The question that is being posed in the community is, can we actually learn how something works without doing it at a scale that brings on the world? And that is like, can I test the medical ethics issues really are relevant, are helpful. Because this is about learning how to do something at the patient's expense. And so.
Which is why the categorization is important, because that's why the analog of geoengineering is the terminal patient. And so the usual norms you might think are exempted.
And let me bring up one last thing, because someone said they were having trouble with responding to the change and responding to the consequences of the change. There is a class of responses that are not quite caught up in what you've done so far that says, okay, the response is sea level rise. Now what can we do about that? And Freeman Dyson, among others, says, well, make it snow extra in Antarctica and pile up snow there that would otherwise have been rising seas and will stay there a long time. So that's so the geoengineering enterprise itself can provide examples of the Jamison engineering.
Okay, that's good. That's a nice example, because that's an example of the cross-cutting categories again. Yeah, so there's a lot in that comment. Just I guess I'll just say two quick things. One is it's an opportunity to come back to something Melissa said about. I mean, part of the thing about, I mean, if you go to the literature of adaptation, I mean, there are lots of people who just want to say there's 16 different kinds of adaptation, and that's where we should make the distinctions, right? But there at least is a distinction that somehow we need to capture between two kinds of things that are going to happen in the greenhouse field. So one thing is going to be this very direct thing that's about crop substitution, for example. And the other thing is going to be destabilized governments in some parts of the world that are going to set off refugee flows, or that are going to be things like statistical increases in particular disease prevalences and things like that, that seem, in a way, to be much more indirect. And it's more of a continuum. You know, it's hard to kind of slice these categories cleanly, but it does seem to be an important distinction worth making, because one kind of response is much more like, I don't know, a diplomatic, political response, and the other kind of response is a much more potentially hardware response. So the other thing is, I have to say, when I was writing this paper, I sort of realized, and Rob, in a way, we're kind of reinforcing each other now, that this 1992 science paper of Nordhaus's is a really deeply symbolic moment where he's running these scenarios for optimal climate policy. And one of them is just stipulated as a geoengineering run, where geoengineering is defined as costless, is hypothetical costless mitigation. And it seems to me that that pretty much is the essence of the concept of geoengineering. And that's why it is just kind of this dream that hangs above the whole discussion.
Colin?
So I had two questions. One was to ask if you could say something more about particular examples of technologies that fall under the rule of geoengineering that you take to be promising. So you're saying rather than looking at the category as a whole, we have to look more on a case-by-case basis. And some of the things that are being talked about might actually be promising. So what you take to be promising, and in particular, why? And so part of the reason I'm interested in why is how evaluating is because of the question I have about the relationship between evaluating particular technologies and this idea of portfolio of responses that you were talking about earlier. So to what extent your explanation of why a given technology is promising appeals to or assumes a certain kind of portfolio in the background that it's operating in conjunction with portfolio responses.
Okay, so in response to the first question, I mean, I would actually like to know what some other people in this room think about that, about what they think about promising technologies. I mean, here's a general perspective that I think is out there that a lot of people have. Solar radiation management has all kinds of pretty terrible problems, I mean, of different sorts, including the fact that it just doesn't deal with the carbon, right? It seems to be and then other problems. So there is a kind of tendency to want to believe that the technologies that will allow you to more effectively sequester carbon or to do air capture are the ones that just for that reason look more promising. Now, technologically, those proposals seem at this point to face pretty overwhelming obstacles from what I know, but we'll see. And as I say, I'm curious as to what other people think. Now, so the idea behind the portfolio of responses goes roughly like this, okay? I mean, the thing is, our challenge is to respond to climate change. Climate change is this hugely complex, multidimensional problem, where that means doing something, it means like sort of dealing with people who are escaping islands that are going underwater, right? It means trying to do something to reduce emissions because we're worried about ocean acidification. I mean, it has to do with things like trying to build public health programs in areas that are going to suffer more from malaria. So the problem is a hugely multidimensional problem. And there's going to be, as it were, a finite amount of resources to deal with this complex multidimensional problem. So we're going to have to actually trade off a public health response from spending more money to do research in air capture. So part of why I'm trying to break down these categories and to look at this more as a portfolio of responses is because that's what I think is just the kind of core policy challenge that we face. And part of the problem when we think in these abstract categories, it just sounds like, well, anything that's in the category of mitigation trumps anything that's in the category of adaptation. So in the climate policy debate, we've been around this track before with mitigation versus adaptation, which was another confused and unproductive discussion where some people said, adaptation's been ignored. We have to spend money on adaptation. Other people said, no, it's a moral hazard against mitigation, and so on. So that's why I want to bring the focus back to the particular policy actions in a comparative way.
Can I just follow up on one of those? Because you said that, I mean, you seem to dismiss solar radiation management as not dealing with the carbon, but my understanding is that at least part of the problem, or at least one of the feedback loops we're getting, is that we're losing ice from the Arctic Ocean, let's say, and therefore we're getting more heat absorbed. So if you can reflect some of that back, maybe by something as simple as painting a lot of roofs white, then you are dealing with that part of the problem anyway, aren't you?
Well, you're not dealing with the carbon, but you're dealing with
that particular feedback loop that now we're absorbing more solar.
Right. So here's the thing. So again, this drives us back to these particular strategies. So if somebody, if the kind of climate equivalent of an NGO says, let's paint roofs white, like Habitat for Humanity roof painting.
White habitat, yes.
White habitat.
Well, that sounds bad.
I mean,
anyway.
That looks pretty good, okay?
Yeah.
And if we say, okay, we're in favor of this solar radiation management scheme, okay, fine with me. If we're talking about launching space mirrors, for example, that's a different proposition entirely.
Sure.
Oh, well, I mean, one big problem with space mirrors just has to do with, again, the issue of control. Who control, I mean, even if you assume that all this can be done and so on and so forth, who controls them? And there's actually the military uses of concentrating energy in space, and these supposed philanthropic uses are actually very, very closely connected to each other. So.
Yes.
Hi, I've got a question about the moral hazard concern which you present, saying that the idea of even thinking about geoengineering activities is going to detract from mitigation and adaptation strategies. Why would you say that's more important than, for example, a reverse moral hazard problem, whereby even the thought of doing something to the atmosphere to undo the bad effects of climate change, that could, kind of galvanize the climate community to mitigate carbon emissions? So the idea of doing geoengineering things, makes you think, have we really got to this stage? Let's stop emitting carbon. Why would you favour your moral hazard argument as opposed to the reverse?
Well, okay, so you're speculating that a lot of chat about geoengineering may actually lead us to do more to reduce emissions. I mean, maybe that's true, maybe that's not true. I mean, what I'm suggesting in the paper is that I think the possibility of geoengineering, which has been there from the beginning, it was, again, the only strategy that was brought to President Johnson in the 1965 Peace Act report, I think has already, the idea of backstopping has figured in many people's mind as well. You know, the smart people will figure this out. It's really a serious problem. So I think in a sense, so I mean, I don't agree with the tenor of a lot of discussion that says, oh, we can't do geoengineering research because there's this, you know, mitigation moral hazard. I think it's been there from the beginning. It's a problem. It's an ongoing problem. I don't know if it's going to be any worse. My worry is on the adaptation side, and I really do think you're starting now to get a rhetoric that's starting to develop on the part of some of the principal players who are really interested in certain kinds of geoengineering technologies, where they're saying, look, climate change, you know, we can live through it, we can adapt in some way, but all those poor people in the developing world, you know, they're really going to have these terrible problems and so on and so forth, and we're probably actually not going to come to their aid in the way that we should and so on, so this is what we're going to do for them. So I see the moral hazard now that we just, you know, the adaptation side. And there I think your speculation doesn't work at all. It's not like we're going to say, oh my God, we're going to geoengineer unless we help people in small island states. You know, we're going to go.
So I'm still having a hard time getting a grip on what the problem is with geoengineering, because a lot of like the arguments looked kind of like they're in principle, but now imagine that it would work. Like imagine that we have like a Promethean dream that actually works, right? Let's do it. Like, who cares? There's no legitimacy. Like, who cares about like, all of these, like do it. Like, if you can solve climate change, that sounds excellent. So a lot of it seems like it's motivated by kind of an underlying skepticism just about the empirics that these types of things can work, that it, you know, the dream is impossible. But people that are promoting geoengineering seem not to be so skeptical. Like, that's why they're in that game, right? And so, like, how much of your worry about geoengineering is in principle, such that you would have these same worries if we knew with certainty that it would work? And how much of it is motivated by like an underlying skepticism in general?
And so look, if we could have costless mitigation, I would be in favor of it.
Isn't that
Right? So what, but what is the which is supposed to work here, okay? Now, I mean, I'm agreeing that there might be some technologies that particularly at certain moments might pass the kind of comparative test I'm talking about. So for example, it's not out of the question, I think, that in 2050, 2060, 2070, 2080, we might be interested in doing some things that we wouldn't be interested in doing now. There'd have to be specific technologies that would have to pass a test in comparison to other technologies. Okay? So I just think there's no technology that's on offer now that is going to be costless mitigation for all the problems that climate change has brought us. In part because climate change is doing so many different things to the planet. And none of the particular technologies that people are talking about are going to be, even if they worked perfectly, are going to be the full range response. So, I mean, if you just stipulate that, how can you be against geoengineering if geoengineering conforms to our fantasy? Well, yeah.
Well, so here's like a way that this would seem kind of, just take like an analogy of cancer research. And someone's like, oh, imagine it's 50 years ago. And we're like, oh my gosh, cancer, like that's so hard to treat. But let's just like, you know, like a lot of little things. Let's do all of that instead of like trying to figure out one big cure for cancer, right? And that is an approach that's happening. But one thing that people are critical of in cancer research is that this approach, like the incentives are lined up such that everybody's doing a bunch of little things and nobody's like looking at like the big thing, cancer. But like there are reasons to think that like we should maybe focus on like the whole like look for a cure, you know? And so there's like a lot of difficulty like finding funding for like cure. It's kind of the opposite problem we have here, right? Like because like it would be really valuable if you could get it, you know? It just seems like, and then there's the same moral hazard problems. We think there's a cure for lung cancer, and people smoke and do a bunch of really bad things, anticipating a cure in the future that's probably not coming out. But
Except,
Yeah, it seems.
but I think part of the problem is you're just assuming away all of the epistemological mess in which we're enmeshed, okay? So the real world decision we have to make is where to put our resources in addressing what particular issues. I mean, go back to my SDI examples, the Strategic Defense Initiative, okay? Ronald Reagan had this amazing idea that no doubt occurred to him while he was clearing brush one day in Santa Barbara, which is, we're going to build this shield over the United States, and nobody's going to be able to hurt us. And not only that, I'm not a bad guy, and I'll prove it, because once we build this shield over the United States that nobody can hurt us, we'll give it to everyone else, and no one will be able to hurt them either. And then we're going to have this really, really nice world in which nobody can hurt each other. Now, what kind of curmudgeon would oppose a dedicated SDI research program if we're building, you know, the utopian fantasy success into the proposal of the program in the first place? Right? The decision we have to make is, given what we know about human institutions, about the challenges we face, and so on and so forth, where do we think the marginal benefits are likely?
Okay, I see one hand, I see two hands at the back now. All right, so we'll take these two questions. Lady in red first, and then we'll come down to you.
Okay. In reaction to that, what about going in a different direction? You might call it population management. Now, this is not scientific. You might imagine encouragement of control or maybe reduction in populations, but also the concept of lifeboats. You know, if islands are about to go under, the world ought to, people of the world ought to have some sort of moral sense that they should come around with lifeboats and move these people to the entire town. Maybe up to the North Pole, I don't know. But I mean, I'm just asking a completely different question about completely different concepts. But I mean, I guess you call it adaptation, I don't know. But I mean, how do you thought about this?
Well, I mean, again, that's part of the decision that has to be made in terms of how we invest our resources. Like, adaptation costs money. And it is that, those activities you're talking about, I'm afraid, gets driven out by the costless mitigation defense.
Okay, and the final question. Great.
Okay, I was wondering why you think there wouldn't be assistance for adaptation in the geoengineering world. And also, on the flip side, is there a moral hazard now for adaptation systems? Is there a Copenhagen fund that really hasn't gone anywhere with adaptation systems? So, you know, is there already why is it there hasn't been a huge amount of assistance for adaptation already?
So this is a really good question, and this is a problem I've been concerned about for a long time. If we think about the climate change problem as sort of starting with emissions, and then the next phase is adaptations, and then, oh my God, geoengineering downstream, right? There's an argument to be had here, but my view has always been part of why you actually want to focus on reducing emissions. There's lots of reasons why you want to do it. But one reason is it's actually going to be easier to get emitting countries, to internalize the cost of their own emissions than it is to actually get them to transfer significant resources to other people offshore who are suffering from their emissions. Okay? I think what we're seeing is, so I don't think I'm wrong about this. I just think that everything is much worse than we might have imagined. Okay? So I think it is still, as it were, more plausible to get people to internalize the cost of their own emissions than to transfer money offshore. And that's part of the problem with these adaptation funds and whether money will really go into them and how it will be spent and so on and so forth. But the reason I think that geoengineering becomes this new moral hazard for adaptation is for precisely this reason. Because now, guess what? It turns out that we can give money to, you know, Princeton, NYU, MIT, Caltech, and so on and so forth, and protect those poor people offshore. Well, that really sounds like a domestic political win. And so that's why I think geoengineering then becomes a moral hazard for adaptation.
Okay, we should close there. It's after 6. I want you to thank both Jamison and Melissa Lane very much.